Dear students, here we see the examples for subgroups. This is a continuation of the previous video. Okay. Now find all the subgroups of the group Z7 minus 0, comma, multiplication modulo 7. Okay. Now what are the elements in Z7 minus 0? That we know that already. 0 deleted, so 1 2 3 4 5 6. Here p, the prime number is 7, so here 7 minus 1, that is 6. So 1 2 3 4 5 6, these are the elements of Z7 minus 0. Okay, now what we have tried all subgroups. Okay, now we know that already this is a group. Okay, this is a group. Okay, to write all the subgroups, now you see, first you write Z7 minus 0 comma multiplication modulo, because each and every set is a subset itself, so that this Z7 minus 0 is a subgroup. Okay, first this one you write, and here the identity element of this group, you know that 1. Okay, because this is multiplication modulo 7, so that the identity element, see here, the identity element and the only element identity element and the multiplication modulo is also a subgroup. Okay, first you write the entire set with the multiplication modulo 7 and the element 1 with the multiplication modulo 7. Okay, both are subset and both are subgroups also. Okay, now we list the remaining. Okay, how? Now you see the second one. Okay, now I listed the elements 1 2 4. Okay, from the set, from the group. I have 6 elements. Here I have 3 elements taken. This is subset. Now I'm going to check this forms a subgroup or not under this multiplication modulo 7. Okay, how? You see here, what is the condition explained in the first slide? You see here, you see the theorem. Let G comma star be a group and H be a non-empty subset of G. Then H comma star is a subgroup of G comma star if and only if this is the condition for a subgroup. Okay, necessary condition, you can say. By this theorem, you see here, you see here, I have taken this subset from this set. This is our set 1 2 3 4 5 6. 1 2 4 is the subset. Okay, we are going to check whether this is a subgroup or not a subgroup. This is a subgroup, yes. How? Now you see here, this is a condition. What is the condition? You see the condition, you take any two element in this subset. See here, you take any two elements and then you check this condition, A star B inverse belongs to H, again in the given set. Okay, now take, for example, I take A is equal to 2. A is equal to 2. I take this element A and I take this element as B. Okay, B is 4. Now what is the condition? You have to check A star B inverse. Okay, what is A? Here 2. Okay, I write here 2. What is B? Here 4. Okay, but what is B inverse? You see, on this question already we derived in the previous video. You see, B is 4. See, for 4, what is B inverse? What is the inverse of 4? That is 2. So that here A already I taken 2. B inverse is here, you see 2, so I write 2. Now 2 multiplied to 4, it is less than 7. So if you apply the modulo, your remainder is 4. So your answer is 4. So what we have to check? You take any two element, you apply this condition, then what you are getting, the answer should be in the set. Yes, this is here. Understand? This is here. Similarly, you have to check, means any two elements you take. See, I taken 2 and 4. I've taken 2 and 4. You can take 2 and 1 and 1 and 4. You check this condition, definitely that is correct. Means your answer again here in the set, definitely. That's why this is a subgroup, no doubt. Okay, okay. See, For example, I'm showing here which is not a subgroup here. Then you understand. You see, suppose I take this 1 to 5, because you can take any subset and then you can verify, you can check the condition for subgroup. Okay, I take 1 to 5. See, 1 2 5, these three elements I selected, okay, in this subset. Okay, now I take a is equal to 2. Yes, I take a is equal to and b is equal to 5. Okay, now again you apply this condition. Okay, what is the condition? A star b inverse. What is a? 2. What is b? 5. But what is b inverse? B inverse of b is here, this inverse of 5 is 3, so that here I put, see, this b inverse I put here 3. Okay, now 2 3 6. Okay, here again the matrix modulo is 7, so this is small. So if you apply that modulo, then you again remainder is 6, so your answer is 6. But you check now, this 6 is inside the set. You check now, this 6 is inside this. No, does not belongs to the taken set. That's why this is not a subgroup. Understand now? So that you can take any element. See, means any one element, two element, three element, four element, five elements, any element, means any subset you can select from the set. But you check this condition, a star b inverse. You check, you find this final answer, it is inside. If it is inside the selected subset, then that is subgroup. You have to check for every two elements. For example, you take 2 4, see, I take 2 4, you take 2 1, you take 4 1, you check, then you list in this one. Okay, that is the condition for subgroup. So now this is satisfied, the number 2, this one satisfied. That's why can say this is a subset. Now you check 6 and 1. I I selected the element 6 and 1 in the subset. Then I check this condition. Yes, that is correct. That's why this is also a subgroup. So now what are the possible subgroups of this group? Only these four: the entire set and this singleton set 1, that identity element set, and then these two sets. Okay, are four subgroups of this group. Oh, z7 minus 0. Understand? See, actually this one you need, but no need to write in the exam for this one, and this one you need, see, to show you what is the inverse for b. Just I pasted here, but it is not required to write in the exam. Okay, and why this is required? You see here, 2 4 1 is a subgroup actually, which means it is also satisfying all four properties. Okay, all four properties, which means closed, associative, identity, inverse. For example, you take 2 4. Okay, by closure property, what is 2 4? You see, 2 4 is 1. Yes, 1 is inside. What is 4 2? 4 2 is 1. Yes, inside. And then what is 1 4 or 4 1? See, 1 4. Answer is 4, so 4 is inside. So you can verify that closed property, associative property, identity property, inverse property, all four also satisfied. Actually, if you check this, actually this is the necessary condition. If you check this property is verified, if you take any two elements, if this property is verified, then definitely this is a subgroup. Okay, now no need to check all other remaining four, but if you want to check, you can check. Okay, now here four subgroups are listed for this group. Okay, this is the answer for this example 5. Okay, now you go example 6. You see here, what is the question? Find all the subgroups of the group S3 comma composite. Okay, what is S3 comma composite? This already we studied in the previous video. What is S3 comma composite? That is, S3 is nothing but the 6 permutations listed here. You see in the Cayley table. See, this is sigma 1, sigma 2, sigma 3, sigma 4, sigma 5, sigma 6, like that we listed and we made the Cayley table. Okay, now why I pasted this table? You can see the inverse to our reference. Okay, now you see again in S3, how many elements in S3? 1, 2, 3, 4, 5, 6 elements. But what is here? What is here? In the subgroups, you can take any, means you can take any number of elements as a subset, then you check the condition for subgroup. Okay, now you see, as I said in the previous question, you what you have taken first, the whole entire set and then the identity element set. Now similarly, see here S3 the whole set and I is the identity element. We know that I is the identity element. Okay, so I see definitely these two are subgroups. Okay, then the remaining you see here remaining. I selected three elements. You see I 1 2 3 1 3 2 composite means binary operation. Now you see which means I selected this element and 1 2 3 this element and 1 3 2 this element. You see I selected, but I don't know whether it is subgroup, but it is subgroup. How? Again same condition you see here, same condition. This condition you have to check. What is this condition? A comma b belongs to H, A star b inverse belongs to H. Yes. Now you see this is A, this is B. You take this is A, this is B, 132. What is the inverse of 132? You see here, this is the identity element 132. So inverse is 123. So now if you operate 123 again 123 means A star B inverse. I am telling 123 123. You see 123 and then 123. Your answer is 132. Okay, that is also here, which means you check means this, you check this property for this subset. You take any two elements, then again A star B inverse inside this set, which means this is a subgroup, clearly, no doubt. Similarly, you can list. Understand what I'm telling? What I did here for this question, same you have to check for each and every subgroup, which means this is, see, 2 is also a subgroup, 3 is also a subgroup, 4 is also, yes, all the subgroup. Okay, so these are all the subgroups. That is a question. Okay, now you try this one. Definitely this is not satisfying this property, that's why this is not a subgroup of this group. Okay, this is not a subgroup. Okay, you can check. Okay, now you see here why we have written this, why you written this. See, this is a subgroup. Okay, we completed, but here what is this? See, in this subgroup you take any one element. For example, I take this element 2 and then through this number 2 I generate all the elements. Yes, this also you can check. Already we are saying 4 questions for cyclic group. Okay, see here this is a subgroup. Sure, now you take any element. For example 2 I take. Now you check whether this element is generating. Yes, 2 is generating all these 3 elements. Okay, that's why 2 is a generator for this subgroup. Okay, that's why this subgroup is equal to this. Okay, see 2 generating, see the generator 2 with respect to the binary operation multiplication model of 7. So that similarly, see for this is the generator, the element 6. Similarly here also, see actually this is a subgroup we have completed, but this equal to this, which means this element 1 2 3 generates this subgroup. That's why this is called generator. Now here I comma 1 2, this is a subgroup, but 1 comma 2 means 1 2 is a generator for this subgroup. Similarly you can write for everything. Okay, so that these all 6 are subgroups of S3 comma composite. Okay, that's it. Thank you.